chapter 35, the coordinate geometry chapter, in my new book, Overcoming ACT Math by Sophia Garcia. It's available on Amazon if you'd like to purchase it. So before we get started, I just wanted to note the first couple of copies of this book that did get sold had some typos in it that I didn't catch. Again, there's only like 7 people that bought that, but just in case you're one of those 7 people, just know that number 3, 4, and 5 need to be changed a little bit. Number 5, the answer is also B. So there was just some typos and stuff I forgot to include in the problem, so this would be the new answer choices, and I had to add this to number 4. And you could just pause if you're one of those people to see, and then just remember this problem's all the same, it just has a different answer choice. Now that we've gone over that, what I want to do is go over the midpoint formula and the distance formula, because it's the main stuff you need for the coordinate geometry chapter. So the midpoint formula is this right here, where this is x1, x2, and this is y1, y2, where those are basically your endpoints. So they could give you endpoints of, let's say, 1, 3, and then you could say maybe 4, 5, whatever. This could be your x1, y1, and this could be your x2, y2. To find the midpoint, you would just add those up, like 1 plus 4 divided by 2, and then you would do the same thing with the y's, 3 plus 5 divided by 2, because it's the halfway point, the midpoint. And then for the distance formula, it's the same thing where it's y1, y2, x1, x2, like you're given 2 points, and then to find the distance between them, you would just plug in what you label as x1, x2, y1, and y2. So yeah, that's basically the main stuff you need to remember and be reminded about before we get started. So let's go to number 1. For the line below, B is a point on AC. If AB is 20 inches and BC is 34 inches, then what is the distance between B and the midpoint of AC? So let's draw this out. So we have a line segment, AC, and we have some point B, and AB is going to be 20 inches. So 20 inches right there. And then BC is going to be 34 inches. So this is 34 inches. Now, there's a different point, a midpoint, that's going to be about halfway between. So we're looking for this guy, the midpoint. Now remember, the midpoint is going to be halfway in between A and C. So if we know the distance between A and C, which we do, because it would just be 20 plus 34, so that's 54. That's the distance, and we could just divide it in half to see where the midpoint should end up. So we would say it's 54, because 20 plus 34 is 54, divided by 2, and that's going to give us 27. So the midpoint should be at 27. The distance between A and the midpoint should be 27. So this should be 27. Now it's asking, what is the distance between B and the midpoint? So we want to know this right here. Well, that's just 7 past where the 20 is. So it would be 7. And someone asked, what grade is this? This is, it goes over multiple grade levels because this is for the ACT. So it's not one specific grade level, sorry. And then, can you do some algebra 2? Yeah, we're doing a bunch of different stuff. So it's not going to just be like a certain class or anything. Like after this, we're going to do sequences. Then I'm going to take a break for dinner, and then I'm going to come back and do more stuff. So then let's go to number 2. For the figure shown below, point H has coordinates this, and point G has midpoint, has the midpoint of, and point G is the midpoint of FH, and point G has coordinates this. What are the coordinates of point F? So we want to find out this guy right here, point F. So let's call point F X, Y for those missing coordinates. So G is the midpoint. And we know that the midpoint formula says that we can just add up the x's and divide by 2 to find out what the x coordinate is for our midpoint, and do the same thing for the y's. So let's go, and someone just said, just say the grade. We would all like to know. It's not a specific grade level. That's the whole point of the SAT. It's testing you on everything prior to calculus. So what we're going to do is we'll say, okay, I'm going to label my points. So this is going to be -13, 2, and then over 2, 1. And then this is going to be -3/4, 2. So we're going to use the midpoint formula to say if I add up my endpoints, so I'm going to add up -13/2 plus x, And then if I divide that by 2, I should get -3/4 as my x-coordinate for the midpoint. So now what I'm going to do is I can cross multiply, and I could say that this is just going to be -3 times 2 is equal to 4 times -13/2 plus x. So then this would be -6 is equal to, and then these would cross cancel. That's 2, that cancels out to 1. So then it's -26 plus x. And then we could say, okay, we're going to add 26 to each side to get x by itself. It's going to cancel out right here. And then that's going to be that 20. Oh, sorry, I forgot to distribute the 4. Whoopsies. That's supposed to be a 4x. So we have to distribute the 4 because it has to be 4 times this and then also 4 times x. So then we're going to be left with 20 is equal to 4x right here. And then we divide by 4 on each side. And that's going to get that x is equal to 5. So we know that x is equal to 5, so the only option that gives us that would be k. Now, sometimes there will be 2 options with the same correct x value. In that case, you would have to do the same thing but for the y's. And you could do that anyway if you just want to confirm it's 3, but in our case, the only option could be k. Okay, so then let's go to number 3. Again, this is the typo version, so this is the new correct answer choices. So it says, John is moving his pencil along the xy plane. The minimum distance his pencil moves between 2 specific points can be represented by the expression here. If his pencil only moves along the lines parallel or perpendicular to the y-axis, then which of the following could be these 2 specific points? So remember, if we're visualizing x and y-axis, this is the y-axis, this is the x-axis. So it's basically saying that it's just moving up, straight up and down, or straight to the left and right when they're talking about parallel and perpendicular, the lines that would be parallel and perpendicular to the y-axis. So let's see, right here we have that that's 0 plus -4 when we simplify this. So we're saying 0 plus 4, so then, because this is 0 and this is plus 4. So then, let's see, we want to find out what is the 2 specific points. So then we would say, let's see, that's the minimum distance. So then it would be, let's see, which of these would work to be 0 and 4. So let's see. So it's going up by, you could go up by 0 and then to the left by 4. Is what this could say. And then so that would be from one to the other, up by 0 and to the left by 4. So that would be D right here. Because you could say I'm going up by 0 and I'm going to the left by 4 from this. And then the only one that has that would be D. Because if you look from 4 to 4, it's not going up any for the Y's. And then for the x's, it's going to the left by 4 to get from 1 to -3. So you just have to look at each of them and see which one is doing that transformation, basically. So then let's go to number 4. 3 points lie in the standard xy coordinate plane. Point G splits FH into FG and GH. The ratio of FG to GH is 1 to 2. Which of the following could be the coordinates of point H? So this is also, I added these points in the new version. So what we're going to do is let's draw this out so we can visualize it. So we have this line segment FH, and then we have G right here, and it says that the ratio is 1 to 2, so let's say that this is 1x, or just x is what we say, because we don't write the 1, and then we would say that this is 2x, so it's 1 to 2. And then we have the points that we'll label here as well, -3, 1. And this is going to be 2, 4. And we'll call h x, y for the missing coordinates that we're solving for. So let me just take a second to look at this. So we could say, let's do, this would be distance formula. Because you could say that the distance of FG, so the distance from here, FG, distance of FG equals what x is. So then you would just use the coordinates and plug it into the distance formula. And we could say that this could be, let's say that, which one's going to be easier? Let's do that this is x, or sorry, not x2, x2, y2, and this would be x1, y1. And then we just have to do the distance formula, which says that basically you subtract the x's and square it, and you add it to the subtracted y's and square it. If you need to be reminded, it's in chapter 4 if you have this book. So we're going to say 4 minus 1 squared plus 2 minus negative 3 squared is going to give us that when we plug that into the, the distance formula. And then we're going to say, okay, now we're going to simplify inside there. So it's going to be that x is equal to 3 squared plus, minus a minus is plus, so this is going to be 5 squared. So then x has to be equal to, 3 squared is 9, 5 squared is 25, so 9 plus 25, which is going to be 34. So it's the square root of 34. Now remember, we know what the ratio of these distances are. So we know that the whole entire line would be x plus 2x for that whole distance from f to h. X plus 2x is 3x. So that means that the total distance of fh, so the distance of fh is equal to 3x. So then what we can do now is we know what x is, so then I'm just going to multiply by 3, because it's 3x to find this. So 3 times root 34. I got it wrong. No, I didn't. This would be 4 minus 1 squared plus 2 minus negative 3 squared. Yeah, it's subtracting the x's and squaring and adding them together. That's right. And 3 squared is 9, 5 squared is 25, 9 plus 25 is 34, root 34. So then 3 times whatever x is, the root 34. So then let's see, let me get back on track. Sorry, I just wanted to make sure I didn't get that wrong. So then what we're going to do is we're going to say, okay, we took the 3 out. So let's work backwards. And let's say before we took the 3 out, this could have been 9 times 34, because they could have taken the 9 as a perfect square and you take out the 3 for that. And we could say that this would be equal to root 306. So then, let's see, we could use the distance formula to say that the distance of FH is equal to, we know it's equal to root 306, but it's also equal to, if we use the distance formula where we have x comma y as our missing points, we could say that it's equal to y minus 1 squared plus x minus negative 3 squared. And all I'm doing is I'm just plugging in, I'm using these 2 points for the distance formula. And I know that they're equal to root 306 because that's 3x. And then I could just simplify this and plug in my points to see which one's the correct one. So let's simplify this. So then that would be root y minus 1 squared plus x plus, that's 3 squared. Whoops, my 3 looks bad. Sorry, guys. So then you would just plug in the points to see what's the correct answer choice. So let's start with 1 comma negative 6. So 1 comma negative 6. If I plug that in here, I'm going to get the square root of negative 6 minus 1 squared plus, and then it's going to be 1 plus 3 squared. And I have to see, okay, is that going to equal, because remember it's equal to root 306. So let's see. This would be negative 7, so negative 7 squared would be 49, so that would be 49 plus, that's supposed to be 49, and then this would be 4 squared, which is 16, that's not going to give us root 306, so it can't be f. And then you're going to do the same thing with the other ones. So then let's try with it's not supposed to be that one, in the new version it's this, 12 comma negative 8. So it would be 12 comma negative 8. And now we're going to plug that in. So for y, we're going to plug in negative 8, and for x, we're going to plug in 12. So let's do that. So we have negative 8 minus 1 squared plus 12 plus 3 squared, and we want to know, does that equal root 306? So negative 8 minus 1 is negative 9. Negative 9 squared is 81. So this is going to be 81 plus, and then that's going to be 12 plus 3 is 15. So then 15 squared is going to be 225. So 225 plus 81, that is going to be 306. So this does equal root 306, which is what we were looking for. So that has to be the point. So it would be G. Okay, so let's keep going. So we're going to do number 5 now. It says two vertices of rectangle PQRS are located at this. P is 2, 3, and Q is 6, 9. Hold on, I'm going to get rid of someone that's being annoying. What is the slope of PS? So let's see. We have a rectangle, so let's say we have PQ. And it doesn't have to look exactly like this. I mean, obviously, it's not going to be a straight line because they're located at different, like, X's and Y's. It's not going to be, like, perfect like that. But it doesn't matter for the purposes of what we're doing this problem. But, like, if you want to, like, make it exactly on the XY axis how it should look, you can do that. But it doesn't really matter for this. So they said that P is 2, 3, and Q is 6, 9. And then we have that's PQRS, so then we'll say this is R, and this is S, because it's a rectangle. Whoops. Okay, so we want to know the slope of PS, the slope of this guy right here. Now remember, for rectangles, they're forming right angles for each of their corners. So these form a right angle, which also means they're perpendicular to each other. So if I can find the slope of PQ, I can then take the negative reciprocal and have the slope of PS, because it's the perpendicular line. Perpendicular lines have negative reciprocal slopes. So let's find the slope for PQ. So to find the slope for PQ, I'm just going to plug that into the slope formula. So PQ slope is equal to, and we're just going to subtract the y's, so 9 minus 3 over the subtracted x's, 6 minus 2. So that's going to be equal to 6 over 4. And then if we simplify that, we could say 2 is the biggest number that goes into 6 and 4. So that would be 6 divided by 2 is 3, 4 divided by 2 is 2, so 3 halves. That's the slope of PQ. Now we want to know the slope of PS, which is perpendicular, so we have to flip this and take the negative. So negative 2/3. So it would be B. So then let's go to this one right over here. If the midpoint of BC is located at 3, 2, and C is located at 11, 13, then what is the y-coordinate of point B? Oh, hold on. I forgot to do something. It's 6:55. Hold on. 1 second. Wait, is this supposed to be at 6? Yeah. Sorry, guys. Okay, so let's go to number 6. If the midpoint of BC is located at 3, 2, and C is located at 11, 13, then what is the y-coordinate of B? Okay, so BC is the midpoint, so let's draw this out. So we have BC. Again, like with this stuff, you don't have to really worry about like drawing it exactly how it looks. Like obviously, if you're graphing this, like this point's going to be way up here for 13 being the y, and this one's going to be like down here for the y being 2, but it doesn't really matter when you're like just drawing it for the purposes of distance and midpoint. So that's why I'm not doing it like exactly how it's supposed to like look, but it doesn't matter. So let's say that B is x, y, this missing point that we don't know, and then we have the middle point, the midpoint, which is going to be 3, 2, and then we have C, which is going to be 11, 13, they told us. So then we want to find out what the y-coordinate of point B is. So remember, we can use the midpoint formula to help us. The midpoint formula says that if we add the y's for the endpoint, we can get what the y is for the midpoint, and the same for the x's, but in this case, we just want the y. So if I add up the y's for the endpoints, y plus 13 and I divide by 2, I should get 2 for my y for my midpoint. So I'm going to multiply each side by 2 to get y by itself. And then I'm going to subtract 13 from each side. And that's going to give me that y is equal to -9. So that would be h. Thank you guys for liking and sharing the live. So then let's go to this one right here. It says we're going to use this for the next 3 questions. So we have this parallelogram right here. And it says for number 7, what is the distance in coordinate units from F to H rounded to the nearest whole number? So we want the distance of F to H. So the distance between these guys right there. So that would just be distance formula because we have 2 points, so we can just plug that into the distance formula. Also, one thing to mention is people do the distance formula differently. Like you can start with the x's or you could start with the y's. It doesn't matter like what order you add them in, just so you know. So sometimes I like start with the y's, sometimes I start with the x's. It doesn't really matter. So for this one, let's label our points first of all. So let's say that this is going to be, let's say that this is going to be 1. So this will be point 1. So this will be y1 and this will be x1. And then this one will be x2, y2. So when we're plugging it into the distance formula, we could say that it would be 3 minus, and then it would be minus -3. So I'm subtracting the y's and squaring it, and then adding it to when I do the same thing to the x's. I'm going to subtract the x's and square them. So then it's going to be 7 minus -6. And then that's going to be squared. So then I just need to simplify this. Oh, and I meant to put distance of FH. So then the distance of FH is going to be equal to, so this is going to be minus and minus, so that's plus. So 3 plus 3 is going to be 6. So 6 squared is going to be 36. Plus 7 minus -6, minus and minus is plus, so 7 plus 6 is going to be 13, so that's going to be plus 13 squared, so 13 squared, and then let's see, if we add that up, that's going to be, that's 205, so then this is supposed to say squared, sorry, and I meant to put that this is 6 squared before I did that. I was moving ahead, sorry guys, so 6 squared basically, and then you turn it into 36 and all that. But 6 squared plus 13 squared, and then when we do that, we get root 205. So when you plug that into your calculator, that's going to be, because it said to round it, so that's the distance, it's going to be about 14.317, and yada, yada, yada. So if we round this, it said to the nearest whole number. The nearest whole number is 14, so it's going to be B. Someone asked, is this Algebra 1, Geometry, or Algebra 2? The SAT and ACT have a combination of a bunch of different, stuff. Basically, like, up to calculus. And that's not wrong unless I'm, like, looking at it. I don't see anything wrong. And it matches the key. Yeah, it matches the key. So, let me know if I did something wrong, but I don't think I did. If I'm just seeing that I didn't carry a negative or something, I don't know. So then we have number 7. Let's see. Oh, we already did that. So then let's go to number 8. What is the area in square coordinate units of the parallelogram FGH? Hold on, let me get water, guys. FGHJ. So, hold on. Let me actually, now that's bothering me. Like, when someone says it's wrong, I, like, want to look at the key just to make sure that I got it right. Let me see. Yeah, that's what the key says, and that's what the explanation thing says. Yep, it should be right. It's right. So then let's go to number 8. So it says, what is the area in square coordinate units of the parallelogram FGHJ? Remember, we're still referring to this guy right here. So area of a parallelogram is equal to the base times the height. So we know area is equal to the base times the height. Now the base and the height of a parallelogram, don't get it confused with like the slanted stuff. It's basically going to be, base and height are always what make a right angle with each other. So like you could draw down a little like altitude thingy right here, a little height, and you could say that this forms a right angle with this line over here. It can't be this slanted one because that's not going to form a right angle. Base and height have to form a right angle with each other. So let's see, what is the distance from this point to this one? You could use distance formula if you want to, but I see that I don't have to do all that work because it's going just straight across right here. Like the y is not changing, so it's just going and changing in the x direction. So it's going from -6 to 5. So that's going to be a distance of 11 right here. So I know that my base is going to be 11, and now I just have to find out, okay, what is my height? Well, I can also use this point for information on my height. So for my height, this point says that I'm at 3 for my y right here, and I'm going all the way down to where I have y equaling -3 over here. So to get from 3 to -3, just going straight down, that's going to be a height of 6. So then it's going to be base times height, 11 times 6, which is just 66. J. So let's go to number 9. If parallelogram FGHJ is reflected over the x-axis, then what will be the coordinates of the image of point J? So remember with reflections, the easy way that and I've always remembered this since high school, is just the opposite is what changes sign. So if you're reflecting over the x-axis, the opposite, y, is what changes sign. So let's look at what point J is. So point J is 5, -3. So we have 5, -3. We're reflecting over the x-axis, so that means that the y is changing sign. So it has to go from negative to positive. I don't know why I was writing a 4. So it has to be +3. And then this doesn't change at all. The x doesn't change at all. So it would just be A. So now let's go to number 10. If a line segment has endpoints, these are the endpoints, then what is the midpoint of the line segment? So this is just straight up midpoint formula where you say I'm going to add the x's of the endpoints, divide by 2 to get my midpoint x, and then you add the y's, divide by 2 to get your midpoint for y, or your y coordinate for your midpoint. So I'm going to get my midpoint x coordinate, I'm going to add up -2 plus 3 over 2. And divide by 2, and then I'm going to do the same thing with the y's. 12 plus 8, and then I'm going to divide by 2 to get my midpoint y coordinate. So this is going to be 1/2, comma, and then 20 over 2, which is just going to be 10. So then it would be 1/2, comma, 10k.